All right, this is a video on standard form of linear equations, and we'll start with an introduction and do a few solved examples. So here's what standard form is. Ax plus by equals c. And a, b, and c are the coefficients in our equation, and curiously, a, b, and c are often represented as capital letters, but they don't have to be. They could be lowercase letters as well. It's also a tradition for a, b, and c to be whole numbers. So if you get some decimals or fractions, often what is done is both sides of the equation are multiplied by the denominator of that fraction to turn everything into a whole number, okay, or an integer. There's some real clear advantages of standard form, and I'll try to just list some of them here. So one of the real pros is some word problems, and we'll do an example of one, are represented really well in standard form. Not all, though. So some word problems aren't represented well, okay? But some word problems are definitely represented well. And it's straightforward to graph a standard form equation or function. I think the biggest drawback, though, is it's challenging, or not necessarily challenging, but awkward, or it's just another step to find the slope. So the slope of the line is not clearly, is not explicitly part of the equation. A and B can be positive, can be negative. C is traditionally a positive number, so if C is negative, you might want to multiply both sides by a negative one to turn C into a positive number, although I don't think that's required. So examples of a standard form equation might be something like 3x minus 5y equals 17, for example. And then just another advantage of this equation, it sort of makes a little bit of intuitive sense. If you have 3 x's and you subtract away 5 y's, you're going to get 17 as an answer for this particular example, and that sort of seems intuitive to me. If you have something like 3/7 x plus 6y equals 4, then what you would want to do is let's just multiply both sides by 7, and that would turn into 3x plus 42y equals 28, and then you would have the equivalent standard form equation, but just with integers there. Okay, so just a couple examples right there. We're going to, actually another con I just thought of is, before we get to our examples, another con is sometimes it's hard to find the equation from just 2 points. And the way I do it is you need to sort of go through another form to get standard form. So if I'm given 2 points, I will find the slope-intercept form first, and then I convert it to standard form. So it's a little bit awkward in that regard. Let's look at a couple examples, and this first one shows just the real clear example of the main benefit of standard form. Often you have problems like this where hot dogs are $2 each and hamburgers are $3 each, and your friends and I spent $36. Or my friends and I spent $36. What's an equation in standard form that represents possible combinations we purchased? So let's define our variables, and we can say D is hot dogs, and maybe B is hamburgers. Okay, and so when you have a couple things adding up to a total, it's a great time to use standard form. So a couple things add up to $36. And we have $2 for each hot dog plus $3 for each burger is $36. So it's just real easy to just translate that scenario right into an equation. Here's the drawback, though. Finding an equation for a line through those points. So we're going to find the slope first. And remember, slope is the difference in the y's divided by the difference in the x's. So that's a -3 over -1. So we have a slope of 3. And let's find a y-intercept, a slope-intercept form, y equals mx plus b form of this equation. And I am going to choose to use that point along with that slope. So we're going to do y equals mx plus b. And so y is 1, m is 3, x is 2, plus our unknown b, okay? So it looks like b, once we subtract 6 from both sides, b is going to be a negative 5. Okay, so we have the pieces of my slope-intercept form equation that we need. Y equals 3x minus 5. But we've been asked to get a standard form equation. So we want all the x's over on the left-hand side. So we're going to get a negative 3x plus y equals negative 5. And I think it's convention to have that constant over on the right be a positive number. So we will then multiply by negative 1. And we get, as a result, 3x minus y equals 5. Okay, so that would be our final outcome there, our final standard form equation. And it's relatively easy to check. You can take your x, y, your points, and plug them in. So for this point over here is 3x, take away 1y, so 3 times 2 minus 1 times 1 is that 5. It checks out. And it should check out for here as well. Is 3 times 3 minus a 4 equal to 5? Yeah, so they check for both. Okay, so it looks like we did it correctly. Real benefit of standard form, I think, is graphing, and we're going to use what I call the intercept method. And so what that means is plugging in 0 for x and then separately plugging in 0 for y, finding a couple points and graphing them. So let's have this first one be our purple equation, and we're going to graph it with a purple line on our axes. So when I talk about plugging in 0 for x, what that really means is making x disappear, okay? And we just have a much simpler equation, 2y equals 6. And so that means if x is 0, y is 3. Okay, divide that 2y equals 6 equation both sides by 2. Then separately, you can make the y disappear. And actually, I made a mistake. So let's correct that. When I plugged in 0 for x, I should not have crossed out that subtraction sign, so that it's equivalent to a negative 2. So what we really have is negative 2y equals 6, so y equals a negative 3. Okay, so that's an important, significant difference, right? And so then we can also plug in 0 for y. And when we plug in 0 for y, the y terms cancel. Let's undo that here. What I meant to do was this. The y terms don't cancel, but they disappear. Okay, so now if we have 0 plugged in for y, 3x equals 6, x is 2. Okay, so we can just graph those points, and let's do it in purple to be color coordinated here. A 0, negative 3 is right here, and a 2, 0 is right here, and we can simply connect the points, try to make a nice straight line, and it looks like we graphed it up. Okay, so we're using the intercept method. For the second one, let's go, how about orange here? Orange there. 4x plus y equals 3, and we're going to get some fractions here, and that's completely okay. But again, what we're trying to do is we're just simply plugging in 0 for x, then plugging in 0 for y. So if we plug in 0 for x, it means x is 0 and y is something. And then when our x term goes away, because we just plugged in 0 for it, it means y is 3. Okay? We can separately plug in 0 for y and try to figure out what x is equal to. So our y term goes away. And I hope you can see that x will be 3/4. Dividing both sides by 4, we get x is 3/4, or 0.75. So once again, we can try to graph these up. We have an over 0 up 3, and we have an over 3/4 up 0 right down in there. Let's see if that works. Okay, that looks pretty good. Okay, so using the intercept method to graph a couple things in standard form. Converting between standard form and slope-intercept form, to go into slope-intercept form, you're just going to solve for y. So I will subtract 3x from both sides here. And I am not going to show all my work, but I'll try to do all the steps. I'm not going to show every piece of what I'm doing, though. Divide by negative 8, y equals 3/8 x plus a negative 17/8. Okay, so we got it into slope-intercept form just by isolating for y. Getting into standard form, we did a similar problem earlier as our first example in this video, but let's group all the x's and y's over on the left-hand side. So we'll have 2/7 x plus y equals negative 5. Let's make that 5 a positive. That is somewhat conventional. Again, I don't know if that's required, but it's what I typically do. And then let's multiply both sides by a 7. So we have a negative 2x minus 7y equals 35. Okay, and so we ended up with a standard form equation right there. All right, nice, we did it. That's a good place to stop.